Hi guys, welcome back to my channel again. So you know that in my previous videos, I have already done the amount of substances and I have covered so many subtopic of amount of substances, how to calculate the concentration, how to work out the amount of the substances, how to work out the mass, and we focused on concentration question. In that we have done the titration question, back titration, number of the water molecule attached. Now with the fresh mood, I want to start a new topic called chemical bonding. Let's do the chemical bonding. Yeah, chemical bonding, we will discuss how a bond is formed. Look at that, we have so many elements in the periodic table and they all are stable. Then think over for a minute why they will make a bond. What's the reason they will make a bond? The two reasons mainly. When they make a bond, they will reduce their energy. One thing. And another thing is to get the extra stability. They will get the electronic configuration of noble gases when they make a bond. So let's briefly discuss about the types of bonding. In the chemical bonding, we have different types of chemical bonds. Let's start. We have interatomic bonding and intermolecular bonding between the two molecules, between the two atoms. Intermolecular bonding. Intermolecular bonding. Any idea about the interatomic bonding? Actually, that's intermolecular bonding is not a main type of bonding. It's a type of force of attraction between the two molecules. This is a main type of bonding. That includes ionic bonding, ionic. Then we have covalent, extension of covalent, which is a dative bonding, dative, and the last one is metallic. First, we will discuss about all these interatomic bonding. Then after that, we will discuss intermolecular bonding. Intermolecular bonding mainly hydrogen bonding, H bonding or hydrogen bonding. We have permanent dipole, PD. I will explain you, don't worry about it. Permanent dipole. Last one, ID, induced dipole. What's the another name of induced dipole, guys? Do we have another name of induced dipole? These are called intermolecular force of attraction. Yes, induced dipole, another name, van der Waal force of attraction. And in some books, it is mentioned as London force of attraction. Okay, let's start ionic bonding first. Can I rub the board? Is that okay? Now, ionic bonding, very important bonding, very important type of bonding, ionic bonding. Okay then. This video is useful for both A-level and GCSE. I want to teach a bit of GCSE stuff today. Let's start with the basic stuff, basic chemistry on ionic bonding. Now, I told you just now, atoms combine together to make a bond. The reason why they combine together, one, to get 8 electrons in the outer shell, or to get the electronic configuration of the noble gases, and secondly, to get the stability by losing energy. Now, look at that. We have metals and non-metals. When you look at the periodic table, you have metals on the left side of the periodic table and a non-metal on the right side of the periodic table. On the very extreme right side of the periodic table, we have noble gases: helium, neon, argon, krypton, xenon, radon. Yep. They have 8 electrons in the outer shell except helium. Helium is 2. Okay? Like you can remember like this. H-E-N-A. Hina is the name of the girl. K-Ziron is the place in China. It's easy to remember like this. So all these elements in the periodic table try to get the electronic configuration of the noble gases when they make a bond. Okay. So metal, the basic tendency is to lose electron. They lose electron, and a non-metal, they can gain electron or they can share electron. But sharing is a different thing. I'm not using the sharing term now. They can gain electrons, lose electrons. What happens when a metal lose electron? Metal can easily donate 1 electron or 2 electron or 3 electron, depend on where they belong, where they're present. I mean, in which group they are present. Okay, let's start the basic thing. Lithium, group 1 metal, sodium, potassium, rubidium, cesium, francium. Okay, in their outer shell, they have 1 extra electron. That is why they placed in group 1. So they have 1 electron in the outer shell, and we are dealing with only outer shell. This is the outer shell, last shell. The outer shell electron is also called the valence electron. So they have 1 electron. Can I give you the example of sodium? Let's take the example of sodium. Sodium has 11 electron in the outer shell. So suppose this is a sodium 11, 1s2, 2s2, 2p6, 3s1. For time being, don't worry about how to write the electronic configuration. Just ignore for now. So look, they have 1, sodium has 1 electron in the outer shell. Okay. When the sodium lost that electron, it can show 8 electron in the outer shell, next outer shell. So take away this electron, sodium give away this electron, and it become sodium ion, Na plus, 1 electron in the outer shell. That loss. So sodium become ion. The positive ion, we call it as cation. Okay. Why it give away 1 electron? To get the 8 electron in the outer shell. Gaining of 8 electron in the outer shell during the formation of the ionic bond represent octet rule. I will teach you octet rule later on. Having 8 electron, what's the octet rule? Octet rule represents the stability of any compound or a molecule by having 8 electron in the outermost shell. Having 8 electrons in the outermost shell during the formation of a bond, any bond like ionic covalent of a chemical bond Okay, sodium lost one electron, having 8 electrons in the outer shell to form ions. Okay, that's fine, yeah? Now, on the other hand, look at the non-metal of the periodic table. Just now explained, non-metals are present on the right side of the periodic table. Let's take halogens. Group 7 elements, okay? What are the group 7 elements? They are called halogens. Let's see. Let's see how many electrons they are present in their outer shell. Why it's easy for them to gain electron rather than lose electron. Okay, look at that, guys. So halogens, they have 7 electrons in the outermost shell. Outermost shell, just now I told you, it's also called valence shell. Now, we are not dealing number of protons or neutrons when we are discussing bonding. It's just number of electrons. Okay. Now, sodium lost one electron. Just now I explained you, and it formed Na plus ion. Now, wait, that electron gone. So halogens, they have halogen series, halogen elements. All these non-metal, they are called group 7 elements, group 7 or halogens. Fluorine, chlorine, bromine, iodine, astatine. They have 7 represent the number of electrons in the outermost shell. Look at that. I'm just drawing the outermost shell. Chlorine has how many electrons in the outermost shell? 1, 2, 3, 4, 5, 6, 7. To get like chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. Just think, which way is easy for the chlorine, to gain the electron or to lose the electron? It has to lose 7 electron to get 8 electron in the outermost shell, which it is likely impossible. Gaining electron for chlorine is easy rather than losing 7 electron. So it's easy for chlorine to gain 1 electron rather than lose 7 electron. Now, chlorine, I'm just drawing outermost shell and the electron in the outermost shell. The electrons which are present in the outermost shells are called valence electron. It has 7 electrons in the outermost shell. That's why all these halogens placed in group 7. Now, chlorine gain 1 electron. Yes, easy. And become Cl minus ion. Look at that. Chlorine has 8 electrons now. 1 electron gain from sodium. Chlorine, Cl, 1 electron, 1, 2, 3, 4, 5, 6, 7, and this electron gained from sodium. Don't worry, I will teach you the Lewis dot and cross structure. I'm just explaining how the ions are formed and how the ions join to make ionic bond. So Cl minus. So we know now when a metal lost electron, it got a positive charge, okay, which is called cation. When a non-metal gain an electron, it becomes a negatively charged ion which is called anion. Anion. Now, we have two ions of oppositely charged particle, Na plus and Cl minus, in the gas form. All are in the gas form. Okay? Negative ion, positive ion, and a negative ion. Now look at that. No doubt they have 8 electrons in the valence shell. Look at that. They follow octet rule. Do you think they are stable? Yeah, because they have 8 electrons in the outer shell. Still they are not stable. Why? Because they are in the gas form. So they have to join and make a bond and turns their physical form from gaseous state to a solid state. Then we will get an ionic compound. Now, they come close together because of the oppositely charged present on there, and they attract each other. When they attract each other, they form a bond called ionic bond. And ionic bonds are non-directional. I will tell you what does it mean. They do not have a perfect shape. I mean a bond. I mean a bond between Na and Cl. We are not drawing the bond like Na-Cl bond. It's just an attraction. Okay. So with that explanation, all these can we define the ionic bond. So write down a question. It can be a GCSE question or A-level question. What is meant by the term ionic bond? Any idea, guys? So it is an electrostatic because it creates electricity. Now write down the definition of an ionic bond, and we will see what are the factors which help in making an ionic bond. Their physical and chemical properties of ionic bond. Let's see the physical and chemical properties later on. Now, what is meant by the term ionic bond? So, first of all, it's a type of an electrostatic attraction between the two oppositely charged ions. Most of the students I've seen, when I ask to my student what is meant by the term ionic bond, they say it's a bond formed between metal and non-metal. No doubt, undoubtedly, it is a bond formed between metal and non-metal, but that's not the true definition of an ionic bond. In terms of GCSE or A-level exam question, if you will come across this question, write down a proper definition. So it is an because of ion, electrostatic force of attraction between the oppositely charged ions or particles. Now, we know what is meant by the term ionic bond. And if you want to further extend your explanation, it is a bond, it is a chemical bond formed between, it is a type of a chemical bond formed between dash and dash. What you want to write between these two gaps? So it is a type of a chemical bond formed between metal and non-metal. Metals and non-metals. How it formed? By the complete transfer of an electron from metals to non-metals, from metal to a non-metal. So that's the complete definition of an ionic bond. It is formed between metal and non-metal. We will see their chemical and physical property and the factors which affect the formation of an ionic bond. Okay guys, for this, go through all this. I want to stop my video here. I will come back with a more explanation of ionic bond and their chemical properties and factors which affects the ionic bond. In the examination, I have seen one question in the examination. I think it's a AQA question from the past paper. The question is like NaCl, MgCl2, and AlCl3. Which one is more ionic? So in my next video, we will focus on these type of questions. Thank you guys. Thanks for